In this video, I'll be defining heat capacity and explaining the two types that exist. So, heat capacity. We represent heat capacity with a C, and sometimes people put a P as a subscript, but it doesn't really matter. Well, the definition of heat capacity is the amount of heat required to change the system's temperature in the system's by one temperature unit. And what will be constant in both types of heat capacity is it's only by one temperature unit. Now let's talk about specific heat capacity and molar heat capacity. So specific heat capacity. So a specific heat capacity is it basically represents the energy required to change 1 gram of substance by 1 temperature unit. So 1 gram of substance by 1 temperature unit. Well, because we said it's energy, the units will be in joules per gram Celsius. Or if you're using Kelvin, it's the same as joules per gram Kelvin. Now, the other type of heat capacity is the molar heat capacity. And it's basically the same as the specific heat capacity, except instead of 1 gram by 1 temperature unit, it's 1 mole, as its name says. 1 mole by 1 temperature unit. So again, it's the energy or heat required to change 1 mole substance by 1 temperature unit. So the units of this one will be in joules per mole Celsius or joules per mole Kelvin. Now, one thing I forgot to mention is that heat capacity, just by itself, has units of joules per degree Celsius or Kelvin. So if they give you the specific heat capacity or molar heat capacity of something and they ask you to find the normal heat capacity, just the heat capacity, or you can just obtain it by using this formula. So heat capacity, if it's a specific heat capacity that they give you, I'm just going to call it CS, then you just multiply by the mass, because we said that specific heat capacity is in joules per gram Celsius. So if you multiply by the mass, this would go, and it would be the same as the heat capacity. So this is for specific. Now if they ask you, if they give you the molar one, the molar heat capacity, you can use the same formula. I'm going to call it Cm, but just multiply by the number of moles. So moles. And just by doing the same, joules, moles, degrees Celsius, and the moles here, it will go, and it will be the same as here. Now let's do some practice problems, just for you to get familiar with them. And the problem is asking, what is the heat capacity of, so, just, wait, wrong color. The heat capacity, if you have 100 grams of water, liquid water, H2O liquid. And they also tell you that the specific heat capacity of liquid water is 4.184 joules per gram of water degrees Celsius. So the first question is, what is the heat capacity? And then they ask you to find the molar heat capacity of liquid water. So using the formula I gave you before, we can obtain Cp using Cs times the mass. And then it would simply be, we have 4.184 joules grams degrees Celsius. We have 100 grams of water here, so the grams will go with the grams, and it would be 4.184 times 100, so our heat capacity is simply 418.4 joules per degree Celsius. Now we have the first part, and they also ask for the molar heat capacity, so we use the other formula. But this time you have to solve for it. So Cp is equal to the molar heat capacity times the number of moles. So the molar heat capacity will be equal to the heat capacity over the number of moles. And you can obtain the number of moles of water just by using the mole diagram. And I'm going to erase this part just to obtain it. So we have 100 grams water, and by using its molar mass, which is about 18 grams, and that's 1 mole. So the grams go with the grams, and we have our moles of water, giving us 5.5 moles. So we plug in the values here. We have this for 18.4 from the previous, from what we obtained at the beginning, over the 5.5 moles. We get 75.38 joules per, let me write it up. So we got 75.38 joules per mole degrees Celsius, because it's molar heat capacity. And that is pretty much all you will see about heat capacity, except when we get to the future stuff, calorimeters and that. But that's it for heat capacity.